If you were to find yourself in the vicinity of a neutron star, it's gonna be bad news. First, you would be torn apart by the incredibly strong magnetic fields. Then the X-ray radiation would blast you to a crisp. And as it pulled you closer, its intense gravity would stretch out your atoms and molecules into a long, thin stream. You would build your speed faster and faster, and you would finally impact the surface, splatter across it, and that process would release as much energy as a nuclear bomb. If I had the choice between falling into a neutron star versus a black hole, I think I'd pick the black hole, because I don't really feel like being torn apart by a magnetic field and blasted with X-rays.
On a cosmic scale, neutron stars may be pint-sized, but they sure pack a serious punch. The secret to all this pent-up power is what's going on below the surface. Armed with the new Kilonova data, we can now take a virtual journey into the heart of a neutron star. First, we must pass through its atmosphere.
Now, it's not like the Earth's atmosphere, which goes up like 100 miles. On a neutron star, the atmosphere is about this deep, and it's extremely dense compared to the air around us.
Below the compressed atmosphere is a crust of ionized iron, a mixture of crystal iron nuclei and free-flowing iron electrons.
Now, the gravity is so strong that it's almost perfectly smooth. The biggest mountains on the surface are going to be less than 1/4 of an inch high.
A 1/4-inch mountain range may sound odd. But things get even stranger as we go below the surface. This is home to the strongest material in the universe. It's so weird, scientists liken it to nuclear pasta.
As we dive beneath the crust of a neutron star, the neutrons themselves start to glue themselves together into exotic shapes. First, they form clumps that look something like gnocchi. Then deeper, the gnocchi glue themselves together to form long strands that look like spaghetti. Even deeper, the spaghetti fuse together to form sheets of lasagna. And then finally, the lasagna fused together to become a uniform mass, but with holes in it, so it looks like penne.
This is pasta, nuclear style.